In this session, let's continue the subgrouping with the point size and hue, which I gave you an introduction in the last session. So I told you that you can introduce size as a hue and can fit the alpha as well. So if you take it here, so I have taken both the commands here. This is the first one where I want to produce hue equal to size. These are the parameters. So size equal to size, hue is equal to size. I want to filter it according to the size. And in the second plot, I have mentioned the same parameters except that I have introduced one more parameter, alpha parameter. So plt.show have shown twice because I want to have two plots. So this is the first plot. You can see the major chunk values, the bigger values have been colored darker. And in this case, it's alpha parameter which has been set. So accordingly, the alpha parameter, the level of transparency is different. So alpha can be anything between 0 and 1. It depends on your. Now, let's discuss something about the line plots. Now, as I told you earlier, that with the help of REL plot function, you can prepare different kinds of plot. You don't need to change the function, only change the kind parameter. Whether you want to produce scatter plot or kind line plot or whatever, you have to simply change the kind parameter, the function. So line plots are simply where the each plot represents the same thing, typically tracked over a period of time. At bit time, how that particular variable has differed is what is being shown with the help of line charts. The line plots are the most used type of plots in the industry, much more used than any other type of. So again, the necessary import. Now again, you need to use the REL plot function, simple REL plot function, and x, y data. And this time, instead of writing kind equal to scatter, you simply mention the kind equal to line, and that's it. You want to subgroup it by day, so you can reduce hue equal to day the way we have done with the scatter. So everything what you have done above with the scatter, the same things you do with the lines as well. Few other things that I have mentioned here is like want to have a style parameter. You want to style your lines according to day. That can also be done. Like here it is as per the location. So every line blue is for the east location. That sorry, dashed orange is for the north and if you want to so style equal to day, hue equal to day, then markers equal to true. So there's a marker variable that you can introduce, and dash is equal to false. So you don't want a dash line. So if you don't want a dash line, you can say dash is equal to false. Otherwise, there is a possibility that when you will use this function or when you will call this function, the interface will show you one or plot with a dash also, just to differ between the lines. So to avoid this, that can be done. This is the basic line plot that you want to draw. Okay, so simple definition of parameters that you need to produce. And this is where you want to subgroups by day and adding markers as well. So to subgroup by day, you have introduced the hue and the style parameter. And if you run this, this is what we get. So this is the first scenario where you not have mentioned anything. It's a basic line plot. This is the third where it is segregated by day. So this yellow line is showing the movements on Saturday, blue line is showing the movements on Sunday, the red line is showing the movements on Friday. And since I have used dashes equal to false, so all the lines are purely solid, none of them dashed format. So if you will not specify this parameter, then some of one or two lines can be of dashed form as well. That totally depend now. And since I have says markers equal to 2, so the markers can also be seen here in line plot, which are not present here in this. Then another very interesting sort of thing which is required in one, which is multiple observations per x value. Let's say your x is r. Now r is 1, 2, 3, 4. Suppose r is my x value and 1 is the value of x. Now for this x equal to 1, there are multiple y values like NO2 for x equal to 1 r. there are multiple values of NO2, multiple values of station, and so on. So this is known as multiple observations per X value. So my X value is equal to 1, which is 1 hour, and then I have different values of NO2 related to that. That is the scenario of multiple observations per X value. And that's a very, cool thing that you can do in your visualizations. It is something which is being encountered a lot by the data analysts, where they find such things where per X value there are multiple Y values. Like for example, in our tips data set, there is a day parameter, like Sunday. So there are many values. So if X is equal to Sunday, let's say for example, then there are many Y values. So total bill values are different for Sunday. Only the day is Friday. There are, so for X equal to Friday, there are many different values of total bill. So multiple X values, multiple uh, per X value, there are multiple Y values. Okay, so multiple observations per X value, that's what we call. So again, we call the REL plot function, and X equal to day. So I'm taking here a value. I'm taking here the X value as such, which has multiple Y values. So we have in our data set, we have X equal to Sunday, Thursday, Friday, and Saturday. Okay. So for X equal to Thursday, there are multiple values of total bill. For X equal to Saturday, there are multiple values of total bill, and so on. And I want to produce a scatter. So this is what I will get for Sunday, for Saturday, for Thursday, and for Friday. Then if I want to produce a line instead of scatter, because scatter is a very flat type of plot which you are seeing here. As such, I don't think anyone can make any visualization out of it, any major visualization out of it. So the another essence is to the line plot. And line plot, if you use line instead of scatter, the remaining things remain same. This is the line what you get. You get a line plot, and then there is a shaded region. Now what this shaded region is all about? So this shaded region is basically showcase the confidence intervals, and it the basic assumption when you use this type of data set is that there is a random sample. Now, by default, it is showing a 95% confidence interval. Okay, so that means we believe that we are 95% confident that mean will lie within this interval only. So whatever is the mean value of our data set, that will lie within the data set, and we are 95% confident with regard to that. So by default, it will give you this type of shaded region, which will show the 95% confidence interval level. If you want to replace confidence interval level with the standard deviation, then you have to mention another parameter here, which is Ci equal to SD. So this shaded region, instead of showing the confidence interval, it will showcase you the standard deviation. As simple as it is. You want to turn off the confidence levels, then again it's very simple. In the Ci parameter, instead of writing SD, you have to write none. Okay, please make sure no single or double quotes are required here. If you will write single or double quote, it will fetch you an error. There is no point of doing that. So if you do that, then you will see only the line, but there is no shaded region, no confidence interval, no standard deviation. So before we move ahead, let's take the interface, how it works. So this is the scenario what we are discussing are multiple the cases where there are multiple observations per X value. Like in our data set, in our tips data set, so we have taken X equal to day, and we have 4 days like Thursday, Friday, Saturday, and Sunday. And for X equal to Thursday, there are multiple values of total bill, which is our Y variable, and so on. So I have produced a basic scatter plot with the help of REL plot function and lt.show, and this is what it. Okay. Scatter plot, not any. I don't believe any major visualization can be done out of it. So what we have done, instead of scatter, we'll put up a line, and let's see how the line plot works. So as I told you that by default this shaded region is the 95% confidence interval here. So that simply means that the mean value of this data set should lie within this region. Okay, that's the ultimate conclusion of this shaded region. If you want to replace this shaded region with standard deviation, because by default it will show the confidence intervals, you have to simple introduce the parameter yeah equal, and if you run this, find uh, that now this is the standard deviation. So higher the broader the shaded region, that means higher the standard deviation, higher the variability of the data, and it's very difficult to trust this type of data. The risk is very high. The lower the standard deviation, the better the data set, the better decision making, the better insights can be made out of it. But if the standard deviation is too large, you see it's majorly covering the entire data set. That means the data set is not very trustworthy in this term. Level of risk is very high. So, and the third scenario where you want to remove the confidence intervals or you don't want to show anything, then you have to mention CI equal to none. And when you do that and you run this, and this is what you get, you will only get a line. There is no shaded region, no confidence interval, no standard deviation, and that is how the entire funda works. So this is uh, what all customizations you can do with the help of the REL plot function. It's much easier to use because earlier in matplotlib we have seen for line chart we are using different type of plt dot line, for scatter plt dot scatter, then there are some difference in parameters as well. REL plot function solves that problem, and that is where the Seaborn scores over the matplotlib library. The next what we have are the count plots and the bar plots. Now, one of the major feature of count plot and the bar plot is that it involves a categorical variable. That means one variable has to be of categorical nature. It cannot be of numerical nature. That is the essential need or essential characteristic before you go for count plot or a bar plot, because both the count plots and the bar plots facilitates comparison between groups. Like for example, this plot which you can see on the right is comparing the level of masculinity of the people, like somewhat masculine, very masculine, not at all masculine, not very, no answer, or whatever case it is. That's the comparison between groups which is being facilitated. Like earlier when we plotted for smokers and non-smokers, so it was a comparison that was happening between smokers and the non-smokers group. Now, so far, with the help of matplotlib library, we have been using plt.count and plt.bar for different type of count and bar plots. But here, the way we are using REL plot, there is another universal function available with the Seaborn library, which is the catplot. Catplot can be used to create any type of categorical data. So it will render you the same advantages of the REL plot which we have discussed above. Because one of the biggest advantage of REL plot or with the cat plot which we are discussing now is that it's very easy to create subplots with the help of the column and the row function. This was a little difficult with the matplotlib library. The matplotlib library introducing column and the row subplot was not so easy, because you have to first define the axis ax dot subplot or plt dot subplot. You have to tell the number of grids and all that stuff. So it was not quite straight with the matplotlib library. But if you use if you are using the Seaborn library and using the catplot or the REL plot function, this is quite straight. There's no rocket science that is involved. Rocket science was not there with matplotlib also, but then it becomes more easy. Simple function. If one is what we have been using is either you can use the count plot functionality or you can use the cat plot. The parameters remain same, except that if you're using cat plot, you have to mention the kind count, because with the help of cat plot, you can produce other type of categorical charts as well, like the bar plot. So you have to mention what kind of plot you are really looking for. You can change the order, the same type of stuff which I told you with the in the REL plot function as well. So you can introduce the category order that you want to know in what category you want to place the bars, and or the count bars, whatever case it is. So sns.catplot uh, x values, because we need a categorical data, only one data is required, x equal to data is df, kind is count, that is the count plot I want, and then the order in which I want to showcase in my plot. Otherwise, it will by default, it might take it like this, it might take it like this, depending upon, but these both are same, depending upon how your data is designed in frame. Okay, or otherwise you can customize as per what we have explained here. Before we go to bar plots, let's make a quick understanding. So if you're using a count plot, so this is when you are using a count plot function. This is when you're using a cat plot function with an extra parameter kind equal to count. And if you run this, you can see both the graphs are exactly same. If you want to change the order, that means you want to place no values first and the yes values later on. You can change that also. So there's an extra parameter order equal to the function that I need to, the parameter that I need to the cat plot function. And if we run this, so now you see the no values have been placed first and the yes values have been placed after the no values. Okay, very simple, straightforward logics. There is no, not at all a very complex matter, that what I will say. So that's all in this session. In the next session, we'll be discussing the bar plots, and till that time, happy plotting.